Okay, now let's start looking at a few of the important properties of the variance. We have seen that the expectation have the linearity property. Do variance have also the linearity property? No, variance do not have the linearity property. Instead, for a linear function of random variable, let's suppose this ax plus b, or maybe let's take this as another random variable, that is y. So this y is a random variable that is a linear function of this original random variable x. So we have already seen that if we have a linear function of random variable, then in case of the expectation we will have the linearity property, and in case of the variance, if we want to find the variance of this linear function of random variable, that is ax plus b, then we will have this kind of relation. So that will be a square times the variance of x, variance of random variable x. So let's look at how we can get this kind of relation for the variance of a linear function of random variable. So we can, let's first of all look at this kind of linear function where we have this random variable x and we are just adding a constant to this random variable x, and we will just see that what will happen to the variance. So let's suppose we have this another random variable y, that is again a linear function, and if you try to look at this what we have assumed is here a is equals to 1, right? So what we are doing here, we have a random variable and we are just adding a constant to random variable, and we want to observe that what will be the variance of this random variable y, or in other words, what will happen to variance if we add a constant to a random variable. So we can find the variance of this random variable y using the definition of variance. What's the definition of variance? So it is nothing but the expected value of square distance from the mean. We have made the assumption here that this alpha is a mean of this random variable y. So what is the variance of y? We are making use of the definition, and what definition says that it is nothing but the expected value of a square distance from the mean. And how we can find this alpha? This alpha is nothing but the expected value of y, and this random variable y is nothing but the again another random variable that is a function of original random variable x, and this function is also a linear function, so we can make use of the linearity property to find the expected value of random variable y. So that will be expected value of x plus expected value of some constant will be constant, and let's assume that the expectation of x is mu. So what we are assuming in expected value of random variable x is mu. So what overall we can write is that expected value of y, that is alpha, is equals to expected value of x, that is mu, plus some constant. Our goal is to find the variance of this random variable y. We can easily put the value of y, that is x plus b. So that will be x plus b minus alpha is nothing but the expected value of y, that is mu plus b. So it will be mu minus b here, right? Square. So this b will get cancelled. What we will get is the expectation of x minus mu square. So what we have got is nothing but same as the variance of this random variable x. right? So what is this? So what this is nothing but the expected value of the square distance from the mean of a random variable x. So this is nothing but the definition of variance of random variable x. So this is what we have got. So here what is happening, if you have some random variable and if you are adding a constant to random variable, what's the effect on the variance? So variance has no effect. So what we have seen, so variance of this random variable y is same as the variance of random variable x. So intuition behind this is that if you add a constant to random variable, some random variable, then that complete distribution will get shifted to right, and the spreadness will have no effect. The spreadness of the probability mass function will have no effect. So we have looked at what's the effect on the variance when we are adding a constant to a random variable. Now let's look at the effect where we are multiplying some constant to random variable this x, and let's suppose this is as another random variable y. Again you can think this, and also you can look at that's what we are assuming here, that b is equals to 0. So we want to just have an observation that what will happen to variance if we are multiplying a constant to a random variable. We can find, so what we want to find is the variance of this random variable y. We can again make use of the definition. What's the definition says? That it is nothing but the expected value of square distance from the mean, and let's suppose in this case also the mean of this random variable y is alpha, and again we can make use of the linearity. So what we want to find is the expected value of this a times this x. Using linearity, it is nothing but the expected value a times this expected value of x, or random variable x. And let's suppose that the expectation of this x is mu again, so that will give you a times mu, right? So overall what we are getting from here is the expected value of random variable y is nothing but the a times the expected value of x. What we can do to find the variance of this random variable y, we can simply substitute this y, that is nothing but a times x. So a times x minus alpha is nothing but the a times mu whole square, and we will have a common. So if we take the common, we will have a square, and inside we will be left with x minus mu. So what x minus mu whole square, and we can again make use of the linearity. This will give you this a square times expected value of x minus mu whole square. Now if you try to look at this, the expected value of x minus mu whole square, it is nothing but the expected value of square distance of random variable x from the mean, right? So this is nothing but the variance of x, variance of random variable x. So what we can conclude, that if you have a random variable y that is a linear function of another random variable x, and if you are adding or subtracting any constant to random variable, then it will have no effect on the variance. And if you are multiplying this a to random variable x, then the variance of this random variable y will get multiplied by a square times the variance of this random variable x. And this is the relation that we have talked about at the start of this lecture, right? So overall point is that variance have no property, no such linearity property. We have this kind of relation, and we have also seen that what will be the effect on the variance if we are adding some constant to random variable, and we have also seen what will be the effect on the variance if we are multiplying some constant to random variable x. So overall effect we have seen here through this relation. So what will be the variance of this linear function of random variable? So we know adding and subtracting will have no effect on the variance, right? So and we are multiplying with random variable -5. So the variance of this linear function of random variable will be -5 square times the variance of this random variable x. So that will be 25 times variance of this random variable x. We have another alternative way of calculating the random variable also, and that we can also look at through the definition of the variance. So let me first of all give it to you what's the other alternative way of calculating the variance, and it is the easy way to get the variance. So variance of this random variable x is the expected value of a square of the random variable minus the expected value of x ka square, right? So we can find the variance directly using this relation also, and we can directly see that this relation has also came from the definition of the variance. So what's the definition of this variance? So if we want to find the variance of random variable x, then it is nothing but the expected value of the square distance from the mean, and let's suppose that the mean of this random variable x is mu. We can expand the square, and that will give you minus 2 times x mu plus mu square. Now we can make here it will be expected value of x square minus 2 times the expected value of x, and mu will also be a constant, so it will be outside, plus expected value of mu squared, since mu is will be some fixed number or constant, so we will have expected value of mu squared that will be here mu square, right? And here this is nothing but the expected value of x square minus, and this is nothing but the expected value of random variable x is nothing what we have assumed is the mu, so that will be 2 times mu square, so minus times of, let me write also 2 times of mu square plus mu square, so overall we will have expected value of x square minus mu square. And how this is nothing, this mu is nothing but the expectation of this random variable x, so we can write like this: expected value of this random variable x square minus expected value, so mu, how we can write the mu is nothing but the expected value of random variable x, and square is also there, so we will have this square, right? So yeah, this is what we have here, the other way of calculating the variance, and maximum time we will make use of this, and it is you will see that this is the simpler way to calculate the variance of a random variable.